Hello everyone. Today we're going to discuss several sections from Chapter 18 in our EasyBuilder Pro user manual. Within this video, you'll learn the basic features of our macro manager and macro workspace. After this, we'll cover the basic form and structure of our macro. And to end our video, we'll review our data types and variable declaration and various operators available for use within our macro workspace. We'll begin by opening the latest version of EasyBuilder Pro. Now before we select our product, I'd like to note that our macro manager is one of several tools that will work with any of our HMIs. Meaning, for this demonstration, you can select any current Weintek product in your possession. Once I've selected my HMI, I'm going to open my macro manager by selecting my project tab. Moving down the list on the right side, you'll notice our macro manager allows us to add, remove, or edit any of our existing macros. And we also have the capability to copy and paste, which often comes in very handy when you're writing several macros with the same format but different addressing. Just below this, we have our import and export functions, which allows us to import a macro we may have used in another project, or export our existing macro so that we can use it later. Our library button will give us access to our macro function library. Our macro function library will allow us to create and manipulate macro function blocks, which we'll discuss in our next video. For now, I'll select Exit and close our function library. After this, I'm going to select New, and with our macro workspace open, I'll select Save and Compile on the bottom right, and then click Exit. Now that a macro exists within our macro list, our Password Protect button will be accessible on the bottom of our macro manager. Our Password Protect feature is a way in which the project developer can guard against unauthorized access to their intellectual property by requiring a password to open the macro manager. And at the bottom of our macro manager, we have the option to select a checkbox, which will allow us to change the data form used to access partial hex addressing within our macro functions. Our dialog box on top shows us the current macros within our project. And just underneath this is our macro under development box, which will contain any macros that have failed to compile. With our overview of the macro manager complete, we'll open a new macro and discuss some of the various features and functions of our macro workspace. Selecting New, as we did in our previous example, will allow us to open our macro workspace. Within our workspace, we have several functions available which we'll discuss from top to bottom. Starting from the very top, we can name our macro or assign a custom macro ID. We also have a security checkbox. Selecting this will allow us to use a local HMI bit to disable our macro depending on the bit's state. Just below this, we have an execute one time checkbox, which effectively makes this an initialization macro. And of course, we can also enable password protection for a specific macro. Again, another feature that allows you to protect your intellectual property. But be warned, you must remember your password. If you forget your password or lose it, Weintek cannot help you recover your macro. On the top left, we have a periodic execution checkbox, which will allow your macro to run on a specified time interval. Below this, we have several additional functions. From left to right, we have our undo and redo buttons, cut, copy, and paste. The flag symbol will allow us to toggle a bookmark, navigate through existing bookmarks, or clear all bookmarks. After this, we have comment and uncomment buttons, which will allow us to write static text. This is how you would create notes within your macro to keep track of the importance of certain functions or variables. You can also insert comments by simply typing 2 forward-facing slashes within your macro body. The Magnifying Glass icon will allow you to find and replace certain items from within your macro. This is an incredibly useful tool for replacing variable names or data types within your project. Now we'll take a look at our API by selecting the Get/Set function button in the bottom left corner. The API can be used in several ways. You can think of it as a cheat sheet to help you build your macro. To demonstrate this, I'm going to make a variable declaration. A variable declaration, in its simplest form, is created by entering the data format of the variable you intend to use, and then by declaring the variable's name. For this example, I'm going to declare a short integer by typing short just under my macro command line, and then enter my variable name directly after it. The variable can be named anything you like, but may not include symbols, with the exception of an underscore. It also may not begin with a number. In this example, I've named my variable var. Now, we'll open our API and discuss some of the features. Again, by clicking our Get/Set button, our API opens. And at the top, we have our built-in checkbox, which will show us the built-in macro functions within our drop-down list. If we had imported a subroutine or function block into our macro function library, our library checkbox would be accessible and allow us to insert our subroutines or user-defined functions as well. Below this, we have a category list. Selecting a category will allow us to filter through our various functions to find one that fits our application. And below this is our function name list. Selecting this drop box will allow us to choose from and use the built-in functions within EasyBuilder Pro. Just as an example, I would like you to scroll down and select Get Data. Looking within our description, we can see that this function is used to retrieve device data. And scrolling down, we can view an example of the correct way in which this function is used. Directly under our dialog box, we can select a variable that we've previously declared to use within our function. On the bottom, you'll notice we can select our read or write address, which could be a local HMI or device register. You could also select a system or user-defined tag as well. And of course, our binary or BCD specification and data count, which should be used when retrieving data from an array. When you finish configuring the following, select OK in the bottom right corner, and you'll have successfully created your first macro using our API function manager. A few quick things before we start adding to our script. On the bottom right is where you'll find our Save and Compile button, which must be selected to validate that your macro is error-free. We also have quick links to run offline or online simulations, which can be helpful during testing. Since we've covered all of the important features, we'll go ahead and explain the proper structure. Every macro has one main function, and typically a set of local variables that must be performed between our macro function main and our end macro command statement, just like the function we've already stated. Above our macro command main, we can create a function block, which is essentially a user-defined version of one of our API functions. And above our function block, we can specify global variables to be used within our script. Following our user manual, the next topic we'll discuss are constant expressions. For numerical data, constant expressions can be assigned by placing an equal sign directly in front of your variable, like this. In this example, I've defined my variable as equal to 100. This can also be done for hexadecimal data as well, but it must begin with a 0x. To address a constant expression of characters, such as ASCII data or even numerical data, we place this in quotes. As an example, I'll define our data format as char, or character data. Our variable name in this case I'll call m. To define a set of characters, it's important to take into account the size of our array. In our case, an array is a numerical value assigned to the size of a set number of elements. For example, say we wanted to initialize our project with a macro that sent the project version to an ASCII object displayed on our home window. Let's then say that this scenario, the version is version 3.1. The character length of the word version is 7. The space is an additional character, and 3.1 are 3 additional characters, bringing our total character count to 11, which can be called the size of our array. So we'll place a bracket in front of our m variable, and then enter in 11. This is followed by a closing to the bracket, and then an equal sign. After this, in quotations, version 3.1. This assigns a constant name to our variable m. The last constant we'll discuss is used by our Boolean data. After identifying your bool variable, which as an example we'll create a bool variable and call it bit, we can then place an equal sign directly in front of it and then type true or false. We can also define our bit as equal to 1 or 0 as a valid assignment. Now, I'll discuss some additional rules for naming variables, as well as which forms of data are valid within our macro workspace. As previously stated, a variable must begin with a letter. A variable cannot possess a name longer than 32 characters. And there are certain names reserved within macro workspace that cannot be used as a variable. There are several different variable types, of which each one I will enter within our workspace, assigning to it a different variable name alphabetically. We can define the following: bool for Boolean data, char for character data, short for short integers, int or int for 32-bit signed integer data, float for our 32-bit float data, long for our 64-bit signed data, and double for 64-bit data. We can also specify our unsigned data as in the following examples: unsigned char, unsigned short, unsigned int, and unsigned long. With this out of the way, it's important to mention that variables must be declared before you use them, and as stated previously, must include the data format of the variable prior to the variable's name. Variables can be named in a consecutive format, meaning that you can specify a data type and then enter several variables consecutively on a single line by ensuring a comma is placed between each variable. This can help you save space in your script. Additionally, you can create up to 4,096 variables within a single macro, assuming you have the time. Also, an array like the one we specified earlier can contain up to 4,096 elements. Also note that assigning constant expressions to variables can be done in two ways, either inside or outside of variable declaration. With that out of the way, we'll begin discussing what we call operators and demonstrate how to use them within your macro script. Operators can be used to modify data and perform calculations, to establish a comparison or create a specific condition that needs to be met, And we can also use logical operators, which help us write logic-based macros. Shift operators to perform bit shifts by a specified number of positions, and of course, bitwise operators. If you're watching this video as an alternative to reading our manual, I would like to mention that there is a priority in which our operations are carried out. Operations within parentheses are carried out first. This is followed by arithmetic operations, and then shift and bitwise operations. Finally, comparison and logical operations, and then variable assignments. That information closes off section 18.4. And I'd like to point out that this is a lot of information to cover in such a short amount of time. With that said, let's recap some of the important topics. Basic macro consists of a set of local variables and function statements. Function blocks and global variables can be used but are optional. Variables are declared by stating the data format first and then a variable name that is less than 32 characters long. Variables must be declared before being used within your statement, and built-in functions can be referenced from our API in the macro workspace. Operators can be used to manipulate your variables and assist in performing complex calculations. Comments can be used to keep track of what you're doing within your macro by placing two forward-facing horizontal slashes within your macro workspace, or by selecting the comment button above your workspace. Now that we've covered our background knowledge, let's move forward and create a macro with some basic operations. Let's start off by discussing our format. Because we haven't learned the correct format to create a function block, we're going to perform our operations in our macro command by hand. So in this case, we'll opt out of using global variables and function blocks. We'll begin by declaring a set of local variables. We can start off by declaring a short, and next to the short, I'm going to create two variables. Our first variable will be named here. And then I'll type a comma and declare our next variable, which I'll call there. When I'm done, I'm going to press enter to get to the next line, where I'll declare a bool. And next to this, I'm going to type bit. Now we've declared a set of local variables. And unless we assign a value to our variables, any computation will have no significance. Because of this, I think it's important to demonstrate the most useful functions within our macro workspace. Opening our API by selecting the get/set button below, we'll scroll down our function list until we find get data. From our read address, we'll select our LW0 address, which we'll define as an object in a bit. We'll assign our variable as the here variable, and we'll leave our data count at 1, and then click OK. This is the correct format for a getData function. And eventually, after you get comfortable writing macros, you can often type this function by hand, much faster than selecting it from our API. Now below our getData, I'm going to make a variable assignment by typing there equals here. Now that we've specified this, we'll select our API again, scroll down our list, and select Set Data. I'll configure my variable to be my there variable and define my write address as LW1. Now we'll save and compile our macro and define two numeric objects in our project. First, I'll create my LW0 object and check the data format to make sure it's 16-bit. After this, I'll do a quick copy and paste and change the address in my next object to LW1. Now, we'll create a function key and select Execute Macro, and select the macro we've just created. If you followed me up to this point, then you've just successfully created your own data transfer per page object. Let's go ahead and run an offline simulation to see our macro in action. Running a simulation, I'll enter a number into our LW0 address, and when finished, I'll go ahead and click our function key. Assuming everything was configured correctly, your data should transfer. Now we'll go ahead and close our simulator and open up our macro again. So in our last example, we used a function key to trigger our data transfer. There's nothing wrong with this, and for some applications, this is completely acceptable. In other applications, you might not want to physically activate this macro, and that's where our periodical execution comes into play. I'll go ahead and check this box. Default execution will happen every 1 second, but this can be changed as needed. Before we compile and close our macro, I think I'll point out some important tips that I forgot to mention. The first is something that was mentioned in one of our previous macro tutorials. This is the ability to copy functions, which can save a significant amount of time during macro creation. As an example, I can copy our getData function, paste it below our assignment, change the G to an S, and it becomes a setData function. After this, I can change the variable to our there variable and our address to LW1 by changing the 0 to 1. Also, just to clear up any confusion, our variable assignment above does not need to occur for a basic data transfer between two equivalent data types. To do basic data transfer, all you need to do is take the same variable you declared in your getData and use that within your setData. There are two reasons I configured our macro in this way. The first is to represent a variable assignment, and the second is to put us into position so that we can add some assignment operators. We'll go ahead and do this. And we'll start out simple by adding a plus sign next to our here variable, and we can place any integer we like after this. For example, I'll put 5. Our macro as it is now will take our data from our numeric object LW0. It's going to call this data here. After this, our macro adds our variable's numeric value to 5 and calls this variable there. And then it's going to send the numeric value of our variable called there to our LW1 address. With that explained, we'll click Save and Compile on the bottom right. Before we exit our macro, I want to discuss one last feature of our macros workspace, that's our white dialog box at the bottom. This box is probably one of the best features about our macro workspace. Say, for example, I missed a variable or forgot a parentheses. If this was the case, and I selected Save and Compile, I would get a few errors. Selecting any of these errors in my Dropbox would reveal the location of each error, and typically some indication as to the cause. For example, I'll click on our first error here, which will bring us to our line with missing parentheses. I'll go ahead and fix this, and then click our next error. Our next error will take us to our line with a misspelled variable. Correcting these and selecting Save and Compile, you'll notice our macro compiles error-free now. So we'll go ahead and exit our macro and run an offline simulation. Entering some data, we can see that our macro automatically manipulates this data so that our output is equal to our input plus 5. That's an excellent and easy example of basic macro operation, and I encourage anyone who might be trying something more complex to test each variable as you go. You can do this by sending each one to different numeric objects. This will ensure that your output is entirely accurate. For our last part, I'll go ahead and close our simulation and create a toggle switch. Our toggle switch can be addressed to LB0, and we can place this anywhere on our screen. Next, I'm going to open my macro and assign a state to our bit variable. As we've discussed before, we can do this in two ways. The first is by making an assignment within the variable declaration, And we can also make an assignment outside of our declaration by simply using our equality symbol. I'm going to assign our variable a state of true within my declaration. And as an example, if I was going to add a second variable in front of our bit, all I would need to do is place a comma, even if I've made an assignment as I did here. Down below, I'm going to write out our setData function using my bit variable. It will be set to our LB0 address and have a data count of 1. After this, I'm going to save and compile my macro and then select Offline Simulation in the bottom right corner. You'll notice that our simulation boots up with our toggle switch set on. Selecting this will turn it off for a short period of time until the macro's periodic cycle switches our toggle switch back on. And that will conclude our introduction to Chapter 18. If you have any additional questions or comments, feel free to post them below. If you found this tutorial helpful and would like to see more, head on over to our YouTube channel and select the Playlist tab. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.